So Algebra 2, taking a look at section 11.5. Okay, so 11.5 talks about probability. An I in there, probability models. Okay, so if we look at probability models, now what we're trying to do is we're trying to figure out a way that we can run a simulation. For instance, we can talk about a woman having 3 kids. Okay, so a woman having 3 kids. We could look at the 3 births and we could say, well, what's the probability that we would get 2 kids? So we could talk about 2 kids here. Well, we got to figure out, well, how are we going to simulate these 3 births? Well, one of the things we could talk about is a quarter. Okay, a quarter or other coin. Okay, so I can just put a coin right here also. If we think about a birth is either male or female. So we could talk about male or female. Okay, so if we have a male, we could relate this to being heads. Female, we could relate to being a tail, or tails. So that way we'll flip a coin once, record what we have. We'll flip a coin twice, record what we have. Flip a coin a 3rd time, and record what we have. So we'll do 3 flips, and then record the results. Okay, and this would tell us out of 3 births there, and then we would repeat it, and then repeat, 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 and then repeat over and over and over again until we have enough trials, and then we come back and look at, well, how many of those gave us 2 kids, or I'm sure it should say 2 kids. Really? Nobody caught that and told me? I mean, come on. Let's say 2 boys, okay? They're all going to be kids, right? So you out of 3 kids, you can't only have 2 kids of what, 1 monster, even though I do have 1 kid and 1 monster at home. That's a different story. Yes, they're both looking at me and laughing right now, trying to figure out which one's a kid and which one's a monster. So we would look at 2 males in here, and then we would come back, we would do our experiment, and then we would look at our flips. Now, what we do have to realize is we have to make sure that whatever's going on, it has to be fair. Okay? So we have to make sure that every chance we have has an equal opportunity of happening. Now, there are some different ways that we can go about this. The quarter is one way to have. Once again, it's not weighted. It's not going to more likely land on a head, more likely land on a tail. But as we flip it, we have to make sure we're flipping in the same manner every time. If we're going to flip the coin and then flip it over in the end, and the next time we just flip it and let it drop, that's a different style of flips. We've got to make sure the styles are the same. So anytime we run a simulation, anytime we run a probability model, we have to make sure that it's done the same and equally for everything. So now let's look at a couple problems, because I would tell you go through, look at the examples, kind of see what they have going on for their experiments, and then we're going to look at some examples here. So here's number 6. Okay, so number 6, they talk about 24 students in math class. We're pretty close. We got 23. The teacher wants to choose 4, so we're going to choose 4. So if I were to write each student's name on a slip of paper, so put the student name on paper, and then put it in a hat and pull out the name. Okay, so then I'm going to put in hat and then draw name. We want to know, is this fair? Okay, so is this fair? So I'm just going to put this. You know, we can put it in a Spanish notation, not in the Spanish word for fair. So we want to know this. Well, let's look at what possibly could happen on here. Here I am. So, as we look at this, well, we need a hat. So I miraculously had my hat on. So what we want to do is we want to take our hat off, and we want to look at the fact that we want to put names into a hat. So I'm just going to use my kids and myself as an example here. So the winner gets a toy. Oh yeah, that's right. They're excited about this. So I'm going to go like this, and I'm going to put an I for my one kid's name. I'm going to put a C for my other kid's name, and then I'm going to put a Mr. T for my name. And so I'm going to put all these slips into this hat, and I'm going to draw out one of them, and the winner gets a toy. Now some of you are looking at this and saying, well, of course I'm going to draw out my name because I got the biggest sheet of paper right here. Well, yeah, that's not fair. Okay, so we need equal size sheets of paper. So if I come now and I get equal size sheets of paper, okay, I get equal size sheets of paper. I now have I, C, and Mr. T. Okay, so I have I, C, and Mr. T. Now I'm going to take my hat here. Okay, I'm going to put my I in, I'm going to put the C in, and I'm going to put the Mr. T in. Okay, now I'm going to draw out the name. Bet you I pull out my name. Wow, yeah. That's fair, isn't it? I got equal size sheets of paper now. Oh, but wait, I didn't shuffle the hat around. Okay, so I better pull all these out. Okay, so I'm going to put the I in, I'm going to put the C in, and then I'm going to put Mr. T in. Okay, now I'll shuffle it, mix it up real good. We'll go there, we'll go in there, we'll mix it up, and I bet you I'll pull my name out again. Oh, look at that. Whose is this? Oh, Mr. T. Okay, so we see that there are some issues that happen here when we put names in a hat on how things go. So now let's think back to our problem. We talked about 24 math students. We're going to choose 4. We're going to put names of there's sheets of paper in a hat with their name on, then draw out. It doesn't say how we're putting them in the hat. So we have to be very specific when we state things. We have to state equal size sheets of paper, well shuffled, folded the same. You have to be very meticulous on all the little details of anything that could be deemed unfair. Now some of you are thinking, well, what about big raffles? And they got like the Mardi Gras raffle that goes on, and they are selling, 100,000 tickets. And then they're drawing out. What you got to think about, because of the vast number when they reach in, even if people fold them differently or if they don't fold them or what, it's going to be impossible to find a very specific one in there because of the number. But when you have such low numbers, you got to be very meticulous on how it is and making sure everything is fair. So do realize if you can think of something that deems it to be unfair, that's what you're going to state it and why it's unfair. Okay? So let's get back to other ways to go about this. Okay, so we're back to our sheet of paper here, and this was unfair. Okay, once again, we can't just put a name on a piece of paper, toss it in a hat, and draw it out. We have to have some object or something that's not going to show that we can tell what's going on or anything. Okay, the next way we can possibly go about things in assigning and trying to figure out is we're going to look at number 8. Okay, so on problem number 8, let me just bring in my sheet of paper over here. Okay, so on problem number 8 now, they talk about the advisor of a Good Citizens Club wants to select 4 of its 25 members. So 4 of its 25 members, okay, to raise and lower the flag each day of the week. She assigns 2-digit numbers from 01 to 25. So basically she has a list where she has 01, 02, 03, 02, 03, ... to 24, 25, and she has everybody's name listed out here. Okay, so 01 to 25. Now what she wants to do is she's going to use a random number table. Yes, that's right. There are tables out there that are just random numbers. There's also properties on your calculators. For instance, this TI Inspire CX calculator, we can pull out and have numbers from 01 to 25, and I could ask it to give me 4 random numbers in there, and it would automatically randomly generate 4 numbers that would be in here. So if we look at that random number table that is right above this problem, I kind of wrote it out, and I do realize in the book it has a little more room, so it can do it a little better. I had to kind of stretch it out, so you're going to see more lines than what the book has here. what we're going to do is we're basically going to take this random number table, and we said we're using 2-digit numbers. Now notice 1 is a 1-digit number, but that's why we put the 0 in front of it, because we have to have equality in here. So if we consider what's happening here, we're going to break our numbers into groups of 2. So if I come through here and I break groups of 2, right here, what we see is we see that these numbers are now forming other numbers. So I have the number 84, 96, 61, 87. So what we do is we go through our list, and now granted these random number tables, there are books devoted towards these, so you could just open up a page and start at one point. Do realize you want everything to be assigned before you start picking your numbers over here. That way you're not showing preference towards anybody here, so you would just assign people down the road. Could be alphabetically, could be however, because once again these numbers can be randomly chosen, so it doesn't matter how they're assigned here, but it does give a blind effort into this. So 84 is not one of our numbers. 96 isn't. 61 isn't. 87 is not. 32, nope. 60, 33. Oh, 0, 1. Okay, so 0, 1 got chosen right here. 95 is not. 36 is not. 58 not. 38 not. Oh, we got 0, 5. So the number 5 is chosen. 25 then. Oh, we got back to back here. 25 is a number that we're going for. 44 isn't. 48, 71. Oh, and then 20. Okay, so what we see is we see that we have the numbers 0, 1, or 0, 5, 25, and 20. So then we would go back to our list, and those would be the 4 people that we selected. Basically, what this gave us is this gave us just a selection process. Now, granted, you could have people fill in their names on whatever number they think superstitiously is better chance or better odds. You know, so many people get superstitious on certain numbers, especially like the lottery. They think, oh, this one has a better chance or not. It's not, okay? It's randomly chosen in here. So we're looking 1, 5, 25, 20 are the ones that are chosen. If we would have started somewhere else, it would have been completely different. Okay, if you notice 0, 3 was right next, then there was 21 here. Here was 19, and then 8 would have been right there. So we see we would have some other ones up and coming. Basically, what you have to remember is in order to keep things fair, in order to keep things random, we have to make sure that we are not predetermining anything or having any bias in there on our part. So if we look at number 10 now, okay, so on number 10 here, 10 talks about a grocery store. Okay, so a grocery store is giving away scratch-off tickets to each customer. They spend over $50. So there are 3 different discount offers randomly and equally distributed among the scratch-off tickets. What is a simulation that can be used to find on average how many times a customer would have to spend over $50 in order to get all 3 different discount offers? Okay, so if you spend over $50, you get a scratch-off ticket. Okay, now on the scratch-off ticket, there are 3 different discounts. Okay, now it asks us to perform a simulation in which we can go in, spend money, and then get all 3 different discount offers. We want to try to describe this. So what we have to do is we have to figure out a way that we're going to have 3 different discounts. Now, do realize we got to go in multiple times in order to find this. It's not going to be, oh, our first 3 times we can get this. Could be, could not be. So one way to do this is we could take a number cube. Okay, so we're going to take a number cube, okay, or a die. Okay, and on here we got 6 sides. Okay, if we notice 6 sides is not 3. But what we do is we could take numbers 1 and 2 is the first discount. 3 and 4 is the second discount. 5 and a 6 is that third discount. And then what we would do is we would roll that number cube and record the result. Roll that number cube, record the result. Roll the number cube, record the result. Roll the number cube, record the result. So as we start recording these results, we would have a list of numbers. Okay, so if I were to perform it, I have my number cube, so I'd have a 5. And I roll it again. Now I have a 2. Roll it again. I have a 6. Roll it again. I have a 6. Roll it again. I have a 4. So if you notice, I now have a 2, a 5, or I'm sorry, a 5, a 2, and then I finally got it. So it took me 1, 2, 3, 4, 5 trials right here. Now I do it again. I would have a 2. Do it again. I would have a 2. Do it again. I have a 3. Okay, so I have a 2, I have a 3. Now I'm looking for a 5 or a 6. Okay, so now I got 4. So I see it would take me spending $250, because once again I got to spend $50 to get this, so $250 to get all 3 discounts. Here it took 4, and what I would do is I would keep repeating this and repeating this many times until I would have a good base to figure out an average for how many times, because I could have some bad luck and have 15 times before I finally get all 3 offers. So what we would have to do here is we would have to write out all this description that I did right here. So do realize in statistics, it's more of an English class than most people think. Okay, you have to be very detailed in your writing. You have to be very descriptive in your writing. You have to write out how you're going to go about this, how you're going to repeat this so it's fair, or how many times you're going to shake the die. You know, I might have rolled them differently, so that could have influenced some of this also. So it's just something that we have to be well aware of as we're going through these problems to make sure that things are fair. But this would be one way to do the simulation. Now, is there other ways to do the simulation? Yeah. There are many other ways to do this simulation. But this is just one of them that kind of related towards, once again, we got to be thinking about, we had 3 different outcomes, and we want to be able to implement a randomness for those 3. Okay. Now do realize we probably wouldn't want to use random numbers on this one because those numbers would be every which way unless we're going to use very large numbers. For instance, we could use 0, 1 to 99, leaving out 0, 0 because that would give us 100 numbers. When we would do that, then we would assign 33 numbers for one, 33 numbers for another, 33 numbers for another, so each are equally likely then, because once again it said these scratch-off tickets were equally distributed in here, so we have to make sure there's some sort of equality. If things are not equal, let's say one was 1/2 of the time, one was 2/3 of the time, or one was, you know, then 1/3 of the time, sorry, and then one was 1/6 of the time. Well, then we would assign 3 numbers to one, 2 numbers to one, and then only 1 number to that third one if they were unequally in there. That way, then we could re-simulate this somehow. Looking at kind of the last one on here is number 12. Okay, so number 12, once again, talks about 24 members in a school's drama club. The advisor wants to randomly select 8 students to help seat patrons prior to a play at the local theater. How can the advisor choose the 8 members? So you want 8 out of 24. Now, once again, we could do like we did back in the simulation up here. We could randomly assign all 24 members to the numbers 0, 1 to 24. So 0, 1 to 24. And then we could go to a random number table and go through it till we get 8 members. Now this could take a little time to figure out, but once again this would show no bias in here. Now if you think about your drama club and everything else, a lot of times it's a seniority thing, so that could also weigh factors into this, but do realize we could also have a 24-sided die. Okay, So what we could do here is we could assign everybody 0, 1 to 24, and then I can get a 24-sided die. I don't have it here, I have it at the school. If we were in class, I would bring it out for you and show you it. But then we would assign everybody, and then I would just roll. So like this number cube here, it would be a die, and I would roll it, and then that would tell me then which one I would then pick first. And I would just roll it 8 times, and those 8 numbers, unless there's a repeat of a number, then I would roll again. And that would be another way to be fair about this. Once again, we probably wouldn't want to put names in a hat. We've seen teachers do popsicle sticks, write everybody's name on a popsicle stick, or assign everybody a number, and then they pull out a popsicle stick, because once again, popsicle sticks are generally equally sized, equal feel, so there's not going to be any bias in there. So what we would have to do for this is we would have to write all this out in words. And once again, as you've seen by my chicken scratch, that's why I'm not writing it out, I'm just describing this to you. And that's this section, okay? So there's going to be a lot of writing in here, a lot of analyze, a lot of common sense, okay? Don't overthink the problems, but definitely do not underthink them, okay? This is a little bit more difficult than our past sections. We don't have formulas to follow. Sometimes there's no right answer. It could go a couple different ways. It's going to really rely on how you explain your problems.